Okay, we're on 6.2 now, binomial, um, binomial distributions. So binomial experiments performed a fixed number of times. Each repetition is called a trial. So sometimes we have 10, flip a coin 10 times, 10 trials. Okay, and there's two outcomes, success and failure. All right, 8 to 15. Who would ask so many problems here? We want to know if they're binomial. So binomial has to have four things. One, fixed number of trials. Two, two outcomes, success or failure. Three, probability of success is constant. And four, the trials are independent. Okay, so this one just says, hey, are these binomial or not? So random sample 30 cars using a car lot's obtained and their mileage is recorded. Not binomial. Which one fails? We don't have success or failure. Okay. Experimental drugs administered to 100 randomly selected. The number of individuals responding is favorably recorded. So, success or failure, favorably or not. All right. So yes, you've got success or failure. You've got a fixed number of trials. Probability of success. Is that constant? What is success? Success is they responded favorably. Well, we're going to assume that of all the people that this drug is going to affect the same people, whatever the percent of people it's going to affect is going to be constant, right? It's going to affect 20% of the whole population well, or 30% or 50%. And the people are independent of each other. 11 or 10. 1,200 registered voters is conducted in which the respondents are asked whether they believe Congress should reform Social Security. Yes, it is binomial. 11, 3 cards are selected without replacement. When you select them without replacement, the probability of an ace changes because you don't put the card back in. Now, if you select it with replacement and you select the number of kings, that is binomial because the probability of selecting a king stays constant every time. Okay, and you're selecting 3 trials, there's success or failure, king or not, and they're independent of each other. 13, you make 80% of her free throws, shoot free throws until she misses. That violates a fixed number of free throws. You gotta have a fixed number. 14, baseball player reaches base safely 30% of the time, is allowed to bat until he reaches. Same thing. We just said need a fixed number of times. Trials. 18, 100 parents with at least one child are surveyed and asked if they've ever spanked their child. Yes or no, you spanked your child. And you record the number who have said yes. So, again, the probability that someone spanks their child is a constant because it's whatever that is. We don't know what it is, but we know that it's going to be the same nationwide. Whether it's 60% or 70% or 40% or 30%, whatever that is, it's constant. All right, that's a lot of talking for that problem, so I hope that helps. I'm sorry if I went too fast. For you, just ask in class if you got more questions. Let's see, 17. A binomial probability experiment is conducted. Compute the probability. Okay, so I'm just going to write this out. 17. You've got 10 trials and 3 successes. Okay, so that's going to be 10C3 ways. The probability of success is 40%. We want 3 of them. And failure is 60%, and we want 7 of them. Okay, so that's what we're looking at. And let me restate that. Okay, I want to have 3 successes. So that's success, 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 and then failures. 4, 5, 6, 7. So the probability of this happening is 0.4 to the third times 0.6 to the 7. How many different ways can I have these 3 successes sprinkled throughout these 10? That's a 10C3. And so you can do this by like that, or you can do binomial PDF 10.43, and if you do that you get 21.5%. 18. You're going to do this. 15 trials, choosing 12 of them, so we know what's probability you have 12 successes, and we've got 85% chance of success, so we got 12 of those and 15 failures. Okay, so this is similar to this, exactly the same, except now I've got 15 of them, and I got an 85% chance of success and 15% chance of failure. Okay, and again that's going to be binomial PDF 15.85. Now don't just say, oh, here, just put it in. Make sure you understand where these numbers are all coming from. Okay, 21.84 and 19 is 40 C38. We're choosing 38 out of 40, and I got a 99% chance of selecting one of them correct. So I'm going to have 38 successes. So I'm going to have 38 successes and 2 failures. Okay, same reasoning. And if I do that, I'm going to get 0.0532. That seems really odd that it's 5.32% chance of getting 38 out of 40 successes when I have a 99% chance of success. Well, it's actually kind of small, because if I have a 99% chance of success, I probably should have 39 or 40 successes rather than 38. Alright, let's do 35. According to flight stats, American Airlines from Dallas to Chicago on time 80% of the time. Suppose 15 are random selected. Explain why it's binomial. Does it meet those 4 requirements? Fixed number of trials. 15 flights. Success or failure, on time or not. Probability of success is 0.8, and we're going to assume that they are independent of each other. So absolutely, success, failure, flights, independent. So there's A. Okay. I actually wrote these out in detail on the first video in this section. Okay, B. Find and interpret the probability of exactly 10 flights are on time. So 10 flights are on time, so that's going to be 15C10, 0.8 to the 10th, and then 2 to the 5th, 0.2 to the 5th, because that's my not on time probability. And I've got 5 of those, right? So remember, it's success 10 times, and then failure 5 times, and then how many different ways can I do that? That's my 15C10. Okay, so there we go, 10.32%, and the way you do that in your calculator, recall, is binomial PDF 15.810. And I just realized I said this really fast, and if you didn't watch the last video, it might not make sense. Okay, why is this formula what it is? If I've got 15 flights, then I could have 10 successes. 2, 3, 4, 5, 6, 7, 8, 9, 10, and 5 failures. Well, the probability of this happening is 0.8 to the 10th, 0.2 to the 5th. Well, how many different ways can I have these successes? Because I can have the successes all mixed up in here. You can have success, failure, you know, all the way out so that you mixed up. However, well, how many different ways can I do that? 15C10. So I got to multiply this or add it up that many times, 1 for each one of these arrangements. And if you do that binomial PDF on your calculator, you get 10.32. C. Probability that X, so if X is on time, number on time flights, C is probability that fewer than 10. X is less than 10. So that means the probability that X is less than or equal to 9 on-time flights. Well, that's the probability of 0 on time, plus 1, plus 2, plus 3. Okay. All the way out to X equals 9 on-time flights. Well, I just want to add all those up. Well, I get to add those up by doing binomial CDF for cumulative, and that's going to be, how many flights did we have? 15. The probability of success is 8, and I want up to 9. So if you do that, you get 0.0611. D. Probability of at least 10 flights. That means 10 or more. Well, that means 10, 11, 12, 13, 14, 15, which I need to add those up. 10 plus probability of 11. Well, I got to add those up individually, or you can recognize, oh, that's just 1 minus the probability that I have less than or equal to 9 flights. Okay, which is 1 minus 0.0611, which is 0.9389, right there. What about the probability that between 8 and 10 flights are on time? 8x less than or equal to 10. Well, that's a probability that you have 8, probability that you have 9, or 10. Oops. Right? Okay, well, that one you just have to calculate those individually. There's not really an easier way to do that for when you have 3 of these. So if you just do it individually, binomial PDF 15.88, that's the first one, plus, and do the others, and if you add those up, you get 0.16. Alright, let it go.